Welcome, students. In this session, let us look at a mathematical approach for the training process of CNN. We looked at the theoretical concepts of training of CNN in the previous video. Now we will go into the mathematical approach, just a skeleton or a framework for a better understanding of the concepts. So now you can see that from the theoretical explanation that your output is based on the convolution process of a filter and an input. Let us assume that we have a 3 cross 3 input with a variable x and also a filter with size 2 cross 2. So when I am overlapping my filter on this original image, I will be able to find 4 positions. So one position is shown in the yellow color shaded item. So you can find that 4 positions are available. So if there are 4 positions, you will get 4 individual numbers which are given by O11, O12, O21, O22. This suffix 11, 12 are nothing but the rows and the columns. The first row corresponds, the first value corresponds to the row and the second value corresponds to the column. So this is the way how you are going to have your output values. Now let us go a bit more in deep and you can find out O11 is equal to the multiplication and summation of the inputs and the filter parameters. So specifically you can say when you want to go for O11, it is the first 4 pixels on the upper left corner which are going to be utilized. So you will get 4 expressions. Now, based on these outputs, now look at this diagram closely. Now, based on these 4 outputs, I am going to adjust my filter parameters and my hidden layer weights. These outputs are denoted by the variable O. And again, my loss function is not directly going to be used for adjustment. We all know that it is based on the differentiation of my loss function. So my loss function is differentiated with respect to O and it is given back using that red color arrow mark. So dou L by dou O. This is what I have. With this, I am going to derive 2 expressions. F corresponds to the filter parameter and X corresponds to the inputs. So if I want to adjust the filter parameters, the expression will be dou L by dou F is equal to, you know the formula, where dou and dou will get cancelled, you will get remaining dou L by dou F. So dou L by dou O into dou O by dou F. Similarly, when you go for dou L by dou X, the same thing is available. Now this dou O by dou X and dou O by dou F, that means the differentiation of the output value with respect to input and filter are called as local gradients. Now, a bit more detailed explanation or the exact equation for adjusting the weights. You can say the filter. Now, let us focus on the filter parameters. Let us see X later. Now, let us focus on F. So, dou L by dou F. How do you adjust the weight values? We already know with neural networks. So, the formula for adjustment is if it is a weight, W nu is equal to W old plus alpha into some differential changes. Here, that differential changes is given by dou L by dou F. So, F updated is equal to F minus alpha into dou L by dou F. So, when it's dou L by dou F is negative, the overall equation becomes positive. When it is positive, it will become negative. So, how do you go for dou L by dou F? You need to first find dou L by dou O, then find dou O by dou F. So first we will go for how to find the dou by dou F. You know expression O11 and also you know how to find the differentiation with respect to F11, F12, F21 and F22. Remember the filter is not a single value but it is a matrix. So for getting single value you need to derive with respect to 4 filter parameters and it is very easy which is nothing but x11, x12, x21 and x2. So for every element of F, generalizing, you can find that this is the expression. So dou L by dou F11, dou F12, dou F21, dou F22. Just expand this as per our previous formula for different values of f. Now the same thing is given. We already know that dou O by dou f is nothing but x, which is based on the f parameter value. If it is f11, then it is x11. So I am replacing the second term with all possible x values. Now we'll come to finding dou L by dou x. For finding dou L by dou x, first you need to find dou O by dou x. So it is the exact reverse of the previous step. Previously we had dou O by dou f, which is equal to x. Now it is dou O by dou x, which is equal to f. So again the same expression for different parameters of x. So x11, x12, x13, 212. So it will, I am showing only a few samples for x because the size of x is bigger. But for f, I have given the complete details because the size of f is smaller. So you can find the values whenever you go for 2, 2, the number of terms you will have is 4. But when you go for 1, the number of parameter is only 1. So putting together, you can say that if it is with respect to f, it is equal to x. If it is respect to x, it is equal to f. So you can generalize that dou L by dou f is also a convolution of input x with the loss gradient of dou L by dou o. In the same way, dou L by dou x is equal to full convolution, 180-degree rotated filter f. This is the only difference between the first process and the second process, and loss gradient of dou L by dou f. So it is easy to find out the values. Thank you, students. We will see this program in the next video.